A research team at a major American university is right now feeding 3D printer code into a machine to recreate a piece of cooling technology that predates the pyramids of Giza by several centuries. They are not building a museum replica. They are testing it as a real solution for real buildings in real heat, because something about it works better than most of what modern engineering has produced since. Two ancient civilizations who never crossed paths, separated by an ocean and roughly 1,000 years, somehow landed on the exact same physics. Stick around, because by the end of this video, you will understand a cooling principle that the multi-billion-dollar air conditioning industry has spent a century trying to make you forget ever existed. Modern air conditioning is younger than your grandparents. The first practical AC unit appeared in 1902. But staying cool in punishing heat is a problem human beings have faced since we first started building shelter. So long before refrigerants, before compressors, before a single watt of electricity existed, two separate ancient cultures quietly solved it. One lived along the Nile and across the Persian plateau. The other lived on the rocky coastline of present-day Oman. Neither one knew the other existed. Both of them built their solution entirely out of clay, carved stone, sand, and water. And in 2025, a research team decided those two forgotten solutions deserved a second look, using one of the most advanced manufacturing tools available today, pots. Take one clay pot. Place it inside a slightly larger clay pot. Fill the gap between them with wet sand. That is the complete invention. There is no battery, no wiring, no electricity anywhere in this device. As the water trapped in that sand slowly evaporates, it physically draws heat away from the inner pot and everything stored inside it. Egyptians used this exact setup, called a Zeer pot, to keep produce edible for weeks and drinking water noticeably cold in temperatures well above 100 degrees Fahrenheit. This is not folklore. The underlying evaporative principle has been documented and used continuously for roughly 4,500 years. Your refrigerator at home achieves the same basic outcome using compressed refrigerant gas and a steady electrical current. The Zeer pot achieved it using nothing but sand and patience. Section 2. A window that breathes. Now travel several thousand kilometers away to the coast of Oman, where a completely unrelated culture was solving the identical problem with a completely different design. Instead of clay pots, they carved elaborate wooden and stone window screens known as Muscatese. These lattice screens were positioned precisely to intercept incoming desert wind. As that hot air squeezed through the narrow carved openings, basic fluid dynamics forced it to accelerate, and that acceleration, combined with subtle moisture held within the carved material, stripped heat from the air before it ever reached the room inside. No machinery, no fuel source, just a continuous, naturally cool breeze flowing through a home in the middle of brutal coastal heat. Walk through older neighborhoods in Oman today, and you will still find original Muscatese screens doing their job centuries after they were first carved. The question that started the 3D printing project. Here is where ancient history collides with modern laboratory work. An architecture researcher partnered with an industrial designer at Virginia Tech and asked one deceptively simple question: what happens if you combine both ancient systems into a single object? The Zeer pot proves that evaporating water removes heat from an enclosed space. The Muscatese proves that forcing air through a carefully shaped lattice cools that air efficiently before it enters a room. Using 3D printing, the research team began producing cylindrical wall partitions engineered to do both jobs simultaneously. The printed lattice structure controls airflow exactly like a Muscatese screen, while embedded water-retentive channels mimic the evaporative effect of the Zeer Pot. Multiple prototype shapes have already been printed and are currently undergoing performance testing in real conditions. The one law of physics behind everything. All of this traces back to a single elegant fact about how matter behaves. When liquid water transforms into vapor, that transformation requires energy. That required energy gets pulled directly out of the surrounding air as heat, which is exactly why the air feels colder, right where evaporation is happening. This effect, called evaporative cooling, has been quietly working in the background of human civilization for well over 4,000 years, completely independent of anyone understanding the underlying chemistry. The Egyptians packing wet sand around clay pots never used the word thermodynamics. The Omani builders, carving wind-catching screens, never ran a single fluid dynamics simulation. They simply observed results across generations and refined what worked. Today's researchers are using sophisticated software to mathematically confirm what these two ancient cultures already proved through pure trial and error. Why? This suddenly matters again. Global electricity demand for air conditioning is projected to triple by the year 2050 as average temperatures continue climbing. Standard AC systems also depend on refrigerant chemicals that significantly contribute to greenhouse gas emissions. A cooling method that requires zero electricity and zero refrigerant is no longer just an interesting historical footnote. It is rapidly becoming a serious engineering priority. The same research team behind this 3D printed system has explicitly stated their long-term goal is producing cooling infrastructure that hot climate regions could deploy without placing additional strain on power grids that are already buckling under rising demand. Building a version at home. Today, you do not need access to a university laboratory or an industrial 3D printer to put these exact principles to work right now. A working version of the Zeer Pot can be assembled at home using 2 unglazed clay pots from any garden center and ordinary sand from a hardware store. A simplified version of the Muscatese cooling effect can be recreated using dampened natural fabric stretched tightly across a window facing the prevailing wind. The same 4,500-year-old physics that kept Egyptian food fresh and Omani homes' comfortable functions identically inside your home today, using materials that likely cost less than a single fast food meal. 2 civilizations, 2 completely independent inventions, 1 identical law of physics connecting them across 1,000 years and an entire ocean. And now, in 2025, advanced 3D printing technology is being used to formally validate what clay, sand, and carved wood already proved millennia ago. If that surprised you even slightly, subscribe right now because next week we are uncovering the underground stepwells of India.